Hello. Today we're going to be covering some basic details surrounding certificates and how they're used in creating secure connections. To start with, what are certificates? Well, certificates are digital files that are used in the encryption of IP traffic within or over a network. Certificates contain several pieces of metadata, or more importantly, they include various pieces of information, not only about a given network element, things like, for example, its fully qualified domain name or its IP address, but they also include details surrounding the encryption that is going to be implemented on a given connection. You'll also see certificates will include things like a validity period or subject and issuer lines. Now, certificates themselves basically form the foundation for something called public key infrastructure, which is basically the framework that's used by network designers to enable secure communication. When looking at certificates themselves, there is a hierarchy that is in play that allows for different elements within a network to trust one another, even though they may not directly know one another. Basically, certificates are a way for a given element in a network to confirm that they are who they are saying they are. Every certificate that you will see in any network or any trace can be described as what's called an identity certificate. Okay. Identity certs are simply certificates that uniquely identify a given server or device or element within a network. They contain specific details that are tied to that particular server or element or device. Now, with that being said, there are going to be some certificates that are very slightly different in their role as opposed to just being a way to uniquely identify a given server, device, or element. These are known as intermediary or root certificates. Now, the kind of overall structure here is that you'll have a baseline or basement certificate that is going to be attached to a given server. And intermediary certificates will basically sit above this base or basement identity certificate, and they begin creating what's called a chain of trust between the base identity certificate and the top layer of this hierarchy, which is the root certificate. The way that this kind of hierarchy works is when you're looking at the various fields within a certificate, you'll have a subject field, which will uniquely identify the particular server to whom this certificate was issued. And then the issuer line is basically going to give you the next step or the next stage, the next pathway up the chain between the base ID cert all the way up to its root. And this process is going to potentially be repeated 2 or 3 times between your base ID cert and the root. Each of those intervening steps are intermediary certificates. Now, in addition to there being these intermediary certificates and a root certificate, these also describe something called a certificate authority. So, a base identity certificate is going to have been created by a intermediary certificate authority, and the certificate authority itself will have an ID cert that was generated or created by the next certificate authority in the chain. Most of the time, you'll have your base ID cert, maybe a single intermediary, and then you'll get to the very top of the hierarchy, which is where the root certificate authority sits. Sometimes certificate hierarchy and structure can be a little more complicated with a few additional layers of intermediary CAs, but the overall concept is the same. You'll have a certificate is created by a certificate authority. That certificate authority certificate was in turn created by either another intermediary CA or a root certificate authority. Now, in addition to the certificate authorities being either intermediary or root, there is sort of one additional classification that can be applied to that certificate authority, and that is whether it is a public or a private certificate authority. Now, functionally, there is no difference between a public and private CA. Where the difference is going to be introduced is in who is managing that particular CA server. So with public certificate authorities, which are also known as well-known CAs, these particular certificate authority servers are managed by third-party companies, for example, ones like GoDaddy or VeriSign or DigiCert. These companies will manage all of the intermediary and the root CA for the given trust chain, and they will have customers that will come to them and will actually purchase their own server certificates directly from these different third parties. One of the major benefits to using a certificate that was created by a public certificate authority is the simple fact that a customer does not have to manage that certificate authority server at all. It's just simply they go to GoDaddy or VeriSign, they pay the amount for their identity certificates, and they will simply be provided that certificate and any accompanying intermediary CAs to go along with that. In addition to that, the other benefit of having a publicly signed certificate is that most PCs, most browsers will automatically trust and will accept certificates from these well-known CAs. So there's basically a nominal fee that is paid, certificates are issued, they can be implemented and installed, and they will basically allow the creation of secure connections fairly seamlessly. If we compare this to private CAs, where a customer may choose to implement their own certificate authority if they have particularly complex certificate needs, or they wish to have control over the specific security details for their certificate authorities, they can set up their own internal certificate authority to manage all of that work themselves. Now, the sort of major downside to using a private CA is that in order for individual devices and elements within a network to trust certificates that are signed by these private CAs, additional work to enable that trust is required. Whereas with public CAs, you simply pay the fee, you get a identity certificate back from the public CA, and you can install it and it will work relatively seamlessly. With private CAs, you have to go through additional work in order to allow certificates signed by your private CA to be accepted and usable by elements within your network. So, with that sort of structure in place, we have our base identity certificate, we have our intermediary CAs, and then we have our root CA at the very top. We'll take a very quick look at some of the important fields within an actual certificate itself. As mentioned before, there are a number of different pieces of metadata that are included within a given certificate. Most of those fields are used specifically in the encrypting of and the securing of a given connection. There are a couple of fields, though, that we'll mention here that are not directly tied into the encrypting of a connection, but they are very important fields because they enable not only the certificate trust chain to be established, but they also set up the validity period for a certificate. So the subject and issuer lines, as we've previously mentioned, describe either the particular server or device or element to which this certificate was issued, or they will define the next hop, the next layer up in the trust chain. So the subject line defines who is this certificate issued to, and the issuer line defines who created, who generated this particular certificate. The other two fields we'll quickly touch on are the valid from and the valid to fields. So these fields control when a particular certificate is going to be valid for. The valid from basically means at any point before the date and time listed in the valid from header or field. Anytime before that, the certificate is not valid. And similarly, when we look at the valid to field, anytime after this date and time, the certificate is no longer valid. This is, without a doubt, one of the most common issues that we see with certificates is certificates will simply expire, and they've expired because the timestamp listed in their valid to field has been reached, or we have gone past it. It's also one of the reasons why certificates have to be fairly regularly regenerated, because they only are valid for a specific period of time, and regenerating the certificate basically refreshes that validity period. So, from a basics point of view, certificates are digital files that are used in securing an IP connection. All certificates are used to identify or confirm an element is who they purport to be. Individual certificates are linked together to form a chain or a hierarchy of trust, which includes the base identity certificate, which is to say a certificate issued to a specific server, device, or element, as well as any intermediary certificates or certificate authorities. And at the very top of this hierarchy is the root certificate authority, or the root certificate. There are a number of fields within a certificate. The majority of them are used for the encrypting of traffic, but there are a couple, the valid to or the valid from, as well as the subject and issuer lines, which are used to create a validity period for the certificate, or to kind of describe the next step or the next hop in the chain between your base identity certificate up to your root CA. In our next video, we're going to look into the negotiation process that is done when trying to create or establish a secure connection, and how the exchange of certificates are used to ensure that the connection is not only encrypted, but that both parties can be certain that they are talking to the correct far end. I'd like to thank everybody for joining us for this session, and we will see you in the next one.